Okay, so here's the BART train. If you had it moving to the left, okay, I'll show you in a minute how it should look different, but we kind of messed up, and I really would rather this look like it's moving to the right. Okay, so if you haven't yet done it, or if you're confused, just do it again and think about it moving to the right. Okay, that's going to be a little easier. I mean, in this picture, I guess it could have been moving to the right. Yeah, but okay, so if it speeds up, the forces are going to be unbalanced. Okay, and I'm going to have the BART, okay, the tracks, and the earth. Okay, you don't want to call it train and tracks because they both start with a T. Okay, so you want to try to choose things that have different letters. Okay, all right. So between the BART and the track, there's going to be a normal because it's a surface. Okay, and there's also going to be a friction. Okay, because those are going to be moving relative to each other. Okay, and also everybody's going to get a gravity. Okay, all right, so we're looking for the BART train. So that's going to be my feeler. Force of gravity is going to go first. Okay, because I always want to add that first because I always know it's there and it's always down. So force of gravity, BART and earth. Okay, and then upward, the track, since it's on a surface, it's going to be pushing it upward. So that's going to be FN BART track. And those are going to be balanced, okay, up and down, because there's no change in the motion of the train up and down. It only happens horizontally, okay? So those are going to be equal. All right, now I have the tricky friction to deal with, okay? And friction is very difficult, so you kind of want to usually draw that last, okay? So I can see that I need the train to speed up, okay? And the only way that that's going to happen is if the friction acts this way. So force of friction, BART train tracks, okay? Because I need this to speed up and it's going to the right, so I have to push it to the right. Okay, so this would be more of a situation that I might consider like a traction, you know, like tires, right? Because remember, as that, you know, this is kind of simplified, but right, let's say that this is a wheel, right? The car is trying to go this way, okay? At this point right here, the wheel is actually moving backwards, okay? Even though the whole car is moving forward, but right there, the wheel is going backwards. So that's sort of, remember the bristles? That's sort of like pushing those bristles backwards. So they want to pop forward, right? So they're actually going to apply a force on the wheel that's going to be forward, okay? As those little bristles kind of try to spring back. Okay, so friction can be tricky, so always kind of put it last, and almost you're using it like to kind of make the force diagram work. That will help you figure it out, okay? Because it's all actually a bit more complicated than this, but in simplest terms, this is how we're going to do it, okay?